Hello everyone, this is Ayushi Gupta. Welcome to the 19th episode of Microsoft Art of Code, brought to you by Millionlights. Millionlights is a TV channel dedicated to improving the skills of people and their employability. Now let me tell you more about the Microsoft Art of Code. Microsoft Art of Code is a series of lectures, courses, and talks by experts who are going to discuss the latest Microsoft technologies and topics related to programming and industry forecasts that are all focused on employability. Today, we are going to learn the C# fundamentals. This is a beginner's course for the people pursuing computer science. These episodes have everything you need to upgrade your skills. These courses are not only beneficial for students, but also for working people. If you are working in an IT firm and wish for promotion, these courses can do a lot for you. If you are certified in C, Java, C++, and SQL, etc., you can get a definite increment in your salary from 6 to 20%. As you know, today we are going to learn C# fundamentals. This content has been created by our partner Microsoft. We have Bob Tabor from Microsoft with us, who will help you learn the fundamentals of C#. But before we start, you need to have a computer system with a 64-bit processor or a 32-bit processor, a Windows notepad, and any web browser such as Internet Explorer. If you want to learn a different programming language, C# is a great place to start. Tune in to learn the basics of C# language and learn to apply them to your programming endeavors like video games, mobile environments, and client apps. Learn C#, get the tools, see how to write code, debug features, explore customizations, and much more. In this C# for Beginners course, let's have a look at what we are going to learn. We have divided the course into 8 parts. In the previous episode, we have covered course introduction, creating your first C# program, understanding your first C# program, and working with code files, projects, and solutions. The topics that we are going to cover in this episode include understanding data types and variables, in which we will add C# syntax to your vocabulary by exploring fundamental building blocks. Data types and variables. We will learn about basic topics such as naming conventions and data type conversions. The if decision statement, in which we will get an introduction to the if decision statement along with the conditional operator. So let's get started.
Hi, I'm Bob Tabor with Developer University. For more of my videos for beginners, please visit me at devu.com. Now in this lesson, I want to get back into talking about C#, the syntax, and we're going to talk about declaring variables, how to choose the right data type for your new variable, and then also how to initialize variables with values. So to begin, let's take a look on screen. If you've ever taken an algebra course, hopefully you've seen something like this, where you're asked to solve for the value of x. And hopefully without a lot of thought, you're able to see that x equals 7, right? So using that same thought process, take a look at this little snippet of code on screen. X equals 7, y equals x plus 3, and then we're going to do a console.write line with the value of y. And hopefully you look at it for a moment using your existing knowledge of algebra, and you think to yourself, well, then it's going to output the value of 10 to a console window, right? Exactly. And so my point is that C#, first of all, is human readable. It's got a few things that might be a little foreign to you, like the semicolon at the end of the line. However, for the most part, I'm willing to bet that as we go through this series of lessons, you'll be able to understand what the code is doing, for the most part, even before I explain it to you. So it's really not that hard. And then secondly, it's probably very similar to things that you've done in the past, like working with math and algebra and things of that nature. And so if we're looking at the C# code, the X and the Y in this context are referred to as variables. And a variable is simply, under the hood, a bucket, I guess you could call it, in the computer's memory. And you put things in buckets and you dump things out of buckets, right? And so we can put values into a given bucket in the computer's memory, and we can retrieve the value out of that bucket. We can even replace what's in the bucket with something different, right? And so that is what you use a variable for. And so this particular situation that we see on screen, these buckets are just holding numeric values. However, we could create buckets that are just the right size for almost any type of information, whether it be individual alphanumeric characters or strings of characters, strings of alphanumeric characters, like even entire sentences and paragraphs and even books. We could also create buckets that are just the right size for dates and times, buckets that are just the right size for really, really, really massive numbers, or even create buckets that are just the right size for numbers that have a lot of values after a decimal point. Now, in this case, what we would expect to see here is that these two buckets, the bucket that's labeled X and the bucket that's labeled Y, would hold numeric values because we want to add numeric values together, right? And so we know that, but how do we express that intent in C#? The instructions that we write in C# will ultimately, after a compilation step, they will ultimately be executed by the .NET runtime that we learned about in a previous lesson. And part of its responsibilities are to make sure to allocate memory for our variables in memory to hold the right kind of data. So here we have two data items, an X and a Y, and we have to tell the runtime that we want to allocate some space in memory that's sufficiently large enough to hold numeric data, like the type of data that we want to work with here in our application. But how do we do that? Well, that's the topic of this lesson. So to get started, what we want to do is create a new project. And here again, I'm going to go to File, New Project. We will go to the New Project dialog and make sure we select the Console Application Project Template. And here we're going to rename this and call this project Variables, and then click the OK button. And Visual Studio goes to work, uses that template, and creates a new solution with a project. And as you can see on screen, here we are back in our familiar program.cs. Obviously, we want to work inside of our static void main in between the opening and the closing curly brace, just like we learned about in our previous lesson. All right. So before we get started, there's one big takeaway from this lesson, and that is that a variable is simply a bucket in memory that you can put data into and retrieve data out of. But we have to tell the compiler, we have to tell the .NET runtime what size of buckets that we want to create. So we have to declare our variables. We have to create those buckets and then give them some label that we can refer to them with from that point on. Now, before we get started here typing some code, all the same rules apply in this video that applied previously. So you have to type the code exactly the way that I type it. Take the time, develop the skill of identifying differences between even small differences, different in capitalization or in spacing or the various special punctuation marks that we use while we're writing code. Develop that skill to identify the differences between what I write on screen and what you're writing in your copy of Visual Studio. All right, and if you see a little red squiggly line, you already know that there's going to be a problem there, right? So that gives you the clue necessary to go and focus either on that exact character or in that vicinity and use your detective skills to figure out what it is that went wrong. Okay, so now let's go ahead and we're going to create two buckets, two variables, and define them in such a way that they're going to hold numeric values. So we'll start with int x and int y, and it's as simple as that. So here, to borrow the explanation that we used earlier, we are asking the .NET runtime to allocate space in our computer's memory sufficiently large enough to hold numeric values. Now we're asking it to create these two buckets, and eventually we're going to put values into them and read values out of them, but at this point we're just declaring their existence and saying, here's what we need to work with. And then after we've declared them, after we've created them in this manner, then we can begin to work with them and assign values, retrieve values from them. But most importantly here, I'm telling the computer that I want to assign integer values into those variables. And an integer is really just a mathematical term that refers to a whole number that's within a certain range. So no values after the decimal point. And as far as C# is concerned, the values have to be between a negative 2,147,000,000 and a positive 2,147,000,000. That's the size of the bucket that we have to work with. If you need to work with much larger numbers, then the int data type is not the correct data type for you. There are other data types to choose from, and we'll learn about some of those a little bit later. If we needed to work with like money values where you have dollars and cents or pounds and pence, then the integer is not the right data type to work with. Okay. Let's continue in our application, and this is basically just to continue what we did in Notepad a few moments ago. So x equals 7, y equals x plus 3, and then we want to do a console.writeLine with the value of y. And then remember, we want to do a console.readLine so we can actually see it on screen without it just flashing and going away immediately. So let's run the application and make sure we get the value that we're expecting. And hopefully you got the value 10 in your copy of Visual Studio just like I got in mine. If not, again, make sure you double check your work against mine. All right, so after we declared the variables in lines 13 and 14, then in lines 16 and 17, I'm doing assignment using the equal sign. Now in this case, we don't really call it the equal sign, we call it the assignment operator. We'll learn about operators in the next couple of lessons. This particular operator, the equal sign, means take whatever is on the right-hand side and assign that into whatever's on the left-hand side. So we're going to say, give me the value of 7 and assign that to our variable, our bucket named x. And the same thing would be true here with y. We're assigning a value into the bucket named y, but we have to do something interesting here. We have to actually retrieve the value of x from memory. So what was x again? Where's that bucket again? Oh, there's the bucket. Dump the value of the bucket out. You're holding the value 7. Add that to 3, and then we assign that to the value of y. Now here we're retrieving the value of y, saying, okay, give me the bucket with y in it, and you dump it out into the console.writeLine, which we know then will print that to screen. And that's essentially assignment and retrieval of variables. Okay, so this is a very simple case. What I want to do now is comment out this code. If I were to begin commenting out the code like we learned about in a previous lesson, I could use the 2 forward slashes. I'm going to show you a different method in just a moment, but notice when I do that, something interesting happens. I commented out the declaration for the variable named x, and when I do that, notice I get these little red squiggly lines underneath x's, and if I hold my mouse cursor there, it says the name x doesn't exist in the current context. And we might say, well, there it is right there. It's in our code comment, but remember, we're telling the C# compiler and ultimately the .NET runtime to ignore that instruction. So the compiler is looking at our code and saying, I have no idea what you're talking about x. I've never heard of x before. I don't know what you want me to do with x. And so it raises the red flag and say, I can't continue on under these conditions. You have to give me more information. Obviously, we can fix it by removing the code comments. All right. Now, what I want to do is comment out several lines of code. And instead of just doing 2 forward slashes in front of every line, which can be laborious, I'm going to comment out multiple lines at the same time using a forward slash and a star character over the number 8 on your keyboard to begin a lengthy comment, and then right here before that read line, actually let's go ahead and keep it all together. After that, I'm going to do a star /. And so now we're going to type another code example beneath that. All right, this one will be a little bit more interesting. Follow along. Pause the video if you need to catch up with me. I'm going to try and type fast just to save time. All right, and before I forget, let's go File, Save All. Great. Now, let's begin here at the top. You can see that this is a different style application with some different commands or different uses of commands that we're familiar with. So we're just going to play a little name game, and we're going to ask, what is your name? And we output type your first name. Now notice in the first case I'm using a right line, which will print what is your name to screen and then use a line feed character to go to the next line. However, I'm using yet a third method from the console object, the console class, which we'll talk about classes and methods later. But this method is different than write line. This will just write out the statement, type your first name, whatever's in between our double quotes there, and it won't go to the next line. It'll just wait there on that line. And then what we're going to do is create a new variable using a different data type, a string data type. So we're not interested in individual alphanumeric characters, so A through Z, 1 through 0, and the special characters. We're interested in a string of them, or a collection of those characters. So not just the individual character B, the individual character O, and the individual character B. We're interested them as a string or a collection as Bob, B-O-B. Okay, so that's what we're declaring a bucket in the computer's memory sufficiently large enough to hold a string of characters, however long that it is. All right, and then what I'm doing is calling our console.readLine method that we're already familiar with, but there's a twist on this. Up to this point, we said we're using the readLine method in order to stop the execution of the application, to wait for the user to hit the enter key on their keyboard, then to resume. However, now we're using it for its real intent, which is to retrieve data from the end user. So in this case, we're asking a question, what's your name? The user types it in and hits enter, and then whatever they typed in is assigned using the assignment operator to the variable we created called first name. All right? Hopefully that makes sense. Now we're going to create a second variable of type string called my last name. We're going to do the same thing here, console.write, and then we're going to allow the user to type in their last name. And then whatever they type in when they hit enter on their the enter key on their keyboard will be saved or assigned to the variable called my last name. Now that we've done assignment to my first name and my last name, I'm merely going to concatenate the values together. So let me point something out. There's several things we need to talk about here. Notice here we were doing actual math where we were adding values together. This is the arithmetic or arithmetic operator. We're basically adding things together, right? Here we're kind of adding things together, but the connotation is different. We're not adding hello and Bob and Tabor with some spaces in there. From a mathematical perspective, we're concatenating strings of characters together to make one really long string. So it's the same operator, but it's used in two slightly different contexts. kind of does the same thing, but we need to understand that there's a fundamental difference in how operators interact with different data types, okay? You'll see why this is important as we continue on through this course. But at the very end here, we're expecting to see hello, comma, space, Bob, space. Notice that I have in here a additional double quote with a space in between to give some spacing between the first name and the last name. And then obviously my last name here. We'll get that one more line of code to write because we need to do another read line so we can see the value on screen. Let's run the application, and we have some things we want to talk about here. Okay, so what is your name? Type first name, Bob, enter. Type your last name, Tabor, enter. Hello, Bob Tabor. Awesome. Okay, so very simple application, but hopefully now we're pushing the envelope a little bit more, learning a little bit more about additional data types that we can use for our variables, and learning about assignment, that it works with all kinds of variables, and then also learning about operators that work differently with different data types. Now, before we get too far, in the previous example, we used merely x and y, which we might expect to see in some mathematical context because we're used to seeing those characters used in algebra problems. But whenever we start writing business applications or even games, we need to give our variables names that are meaningful inside of the program that we're writing. So I could have just used called this X and then done something like this X and then done something like this X. And you look at this and you say, I have no idea what X is supposed to do. All right. It's because we used a very vague description of the bucket in the computer's memory. Instead, you don't have to worry about keystrokes. Make it human readable. Write your code in such a way that somebody can read through it and understand exactly what the variables are doing and what the logic of the application is doing. And then also notice as I go and change some of these things back here to my first name, I used a little feature of Visual Studio that allowed me to say, now that I've changed the name of X to first name, let me rename it everywhere that I've used the word X. Did you notice I did that? I hit the control and the period on the keyboard here. Let's do that one more time. I'm going to change this back to X. Notice that I get the little light bulb here off to the left-hand side, which is quick actions. And then I hit control period on my keyboard. And now it gives me the option to rename my first name to X. And it even off to the right-hand side shows me all of these changes. This is called a refactoring. I'm changing the code just ever so slightly by renaming things to give them more meaning. In this case, I'm doing the exact opposite, but we'll come back to that. So do I want to rename every time I use the variable name, my first name, to X? Yes. So let's rename everything. Bam, just like that. All right. Let's rename it one more time. So my first name, control period, and now I want to rename everything from X to my first name. And you might look at that phrase, my first name, and then again I used it down here, my last name, and you're thinking to yourself, that's a crazy naming convention. Well, it's a naming convention that's called camel casing, where you start with the first letter in a list of words that you're kind of munging together to describe a variable or something along those lines. Use a lowercase for the first letter of the first word, and then an uppercase letter for the second and subsequent words in that variable name. So ideally, it makes it human readable. I can read it fairly easily that way. All right. And at this point, I think it's important also to do something like this. I'm going to rename this to my first name, all lowercase. And remember what we said in the previous video, that C# is a case-sensitive language. So if you were to use the wrong capitalization, then you're going to get a red squiggly line and it says, my first name does not exist in the current context. Do you remember seeing that just a moment ago when we removed the declaration for X up here when we commented it out? The same thing is true here. my first name, all lowercase, is different from the bucket, the variable we define called my capital F, capital name, first name. All right. So capitalization matters. Make sure that you remember that. So in this case, let's just go ahead and change everything back correctly, and we should be good to go again. Okay, great. Now you might be saying to yourself, well, this degree of precision seems pretty difficult. I mean, how am I going to remember exactly what I named things in the past? Well, there are a couple of different tricks for them. Keeping your code methods small, and we'll talk about that later. That's one way to do it. But then the other thing is to rely on IntelliSense, which is that little code window that I told you to ignore before. It's actually pretty important. So as I start typing notice that it pops up beneath what I'm typing, the correct capitalization, correct spelling for any of the variables that I've defined up to this point that start with the letters MY. Now, at this point, what I can do is simply hit the equal sign on my keyboard, and it will type everything else out for me. So I don't have to worry about spelling. I don't have to worry about capitalization. And you may have noticed while I was typing, I was typing and then using arrow keys on my keyboard, and then you couldn't really see my fingers moving, but I wasn't typing every single keystroke. This is what allows software developers to write code very quickly. Once you get used to relying on IntelliSense, one of the tools that Visual Studio gives you in the text editor to make your typing more accurate and allow you to type much faster than maybe you normally could. Okay, we'll come back to IntelliSense later. All right, the other thing that I wanted to tell you about here, or talk about, is that we cannot define the same variable two times. So let's try this. I'm going to go and do my first name and say I want another bucket in the computer's memory with the same name, my first name, and the compiler says you can't do that. We've already got a bucket. We're going to confuse buckets in memory if we give two buckets the same name. Okay, so it says a local variable name, my first name, is already defined in this scope. You can't do that. Now, we could do this, but I highly recommend you don't do that because, again, my first name, all lowercase, is different than my first name with camel case. But this would cause a high degree of confusion, so never do that. Okay? Be descriptive with your variable names. Don't repeat variable names. Always stick to a naming convention and never break that rule. And if you follow those little rules, I think you'll find some of these initial issues, they'll just kind of dissipate. You won't have to worry about them. All right? Okay, so what I want to do now is take a look at this second set of code. And then not only are we in line number 29 declaring the variable, but then in line number 31, we're actually giving it a value. What if we were to rewrite this little passage of code? So I'll go ahead and comment all of this out. And I'm going to make this smaller. In fact, here's what I'm going to do. String my last name equals console.readLine. And then I will say above that, console.writeLine. Type your last name. All right. Okay. So you can see that I took these two lines of code, 29 and 31, and I combined them together. And so what I'm doing here is not only declaring the variable, but then I'm initializing its value to whatever we retrieve when we call readLine. So this is called initialization. And initialization is important because you want to give your variables a value as quickly as possible. This puts your variable into what's called a valid state, which will be an important idea as we learn to write applications, real applications. But also experienced developers like to write less code, and they're always looking for a convenient way to reduce the number of keystrokes that they have to type and reduce the amount of code that they have to read. And so usually you want to declare your variables as you're using them, and not declare them like some people used to do a long time ago, put them all at the very top of a given method or section of code. And so you should get into the practice of two things. Declaring your variables as you need them in the body of your code, and then secondly, if you can, give them an initialized value immediately after you declare them, like we've done here in line number 34. All right? Okay, so tell you what, let's stop right there. I think we've covered a lot of ground for one lesson, right? Let's do a quick recap and just talk about about over a dozen things that we discussed. We talked about what a variable is. We talked about how to declare a variable, how to choose the correct data type. We talked about the int data type and the string data type. We talked about assigning values into variables and then retrieving values out of variables. We talked about the assignment operator. We looked at the arithmetic operator and also the string concatenation operator, which is both just the plus sign. We looked at console.write versus console.writeLine. We looked at the other life of the console.readLine method, that we can actually retrieve the values that the user types in. We talked about camel casing and naming conventions for our variables. We looked at IntelliSense. We talked about how to rename things, how to refactor our code using the little quick action. Remember the little light bulb that we could make changes to by hitting Control and period on our keyboard and then using our arrow keys to make selections and to rename all uses of our variable name throughout our entire code base. We probably talked about a lot more than that as well, but let's go ahead and wrap it up here and we'll start again in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, things are going to get a little bit more interesting. Based on user input, we're going to write logic to execute either one block of code or another block of code. So when I use the term logic, I mean that we're going to make a decision to execute some code based on some condition. That could be the user's input from the keyboard, maybe the state of the computer system itself, maybe some other data that we have access to or available to us. But somehow we're going to make a decision on whether to branch out and execute this code or execute this other code, all right? And so let's begin the way that we normally do by creating a new project. And I'm going to go File, New, Project. Make sure to choose a console application, C# console application, and we'll call this project Decisions and click OK. And what I want to do is we're going to create a little game, and we're going to do it right here in static void main. And I'm going to go ahead and start typing. You can pause to catch up with me. Alrighty, so hopefully most of this will make sense. Let's go ahead and run the application. And here we're going to play Bob's Big Giveaway, and we can choose a door. What's behind door 1, 2, or 3? I'm going to choose what's behind door number 1, and it said, hey, you won a new car. Awesome. Let's play again. I'd like to win something else. And so now we can type in the number 2, and, well, nothing really happens at all. I'm going to hit enter again on my keyboard, and the application just ends. We can try the same thing for 3, but I suspect the same thing will happen with number 2. And I can just type something randomly, and again, nothing really happens here. But let's start at the basics and talk about this if statement that we've created here, which is really the purpose of this lesson in the first place. The if statement is called a decision statement because we will decide whether to execute any of the code inside of this inner code block based on this evaluation that we're going to do after the if keyword. So in this case, what we're doing is evaluating whatever the user typed in, and we're gathering that from the console.readline like we learned in the previous lesson. So the user typed something in, they hit enter. We got that now in the user value variable, and we want to perform an evaluation to see if what the user typed in is equal to this literal string number 1. All right, and so here's where hopefully I want to call your attention to this. You can see that I'm using two equal signs next to each other. So we already learned previously that a single equal sign is actually an assignment operator. We're assigning the value of whatever the user typed in this case, in the console.readline, to the variable user value using this assignment operator. But whenever you use two equal signs next to each other, you're going to do an evaluation for true or false. So whatever's inside of this opening and closing parentheses, we're going to perform an evaluation. Is user value in fact equal to the number 1, or the string character 1, or is it not equal to the string character 1? It can only be true or false. All right, and so based on that, if whatever the evaluation of that expression is, if it turns out to be true, then and only then will we perform the code defined in the code block immediately after that if statement. If that's not true, if this turns out to be a false statement, then we'll just ignore whatever's inside of this code block and we'll continue the execution of our application to line 23 and then beyond. All right, so that's how it works. But I tell you what, this isn't a very interesting example because obviously here we have no prize for door 2 or door 3. And then what happens if somebody just types in 4, 5, 6 or ASDF or whatever on the keyboard? We need to account for all of those scenarios in our application. So let me continue typing in some code here, and you can again pause the video if you need to follow along. But we'll start by using an else if statement right below our code block for the if statement. Okay, so here we go. All right, well, let's stop right there for the moment. And you can see that in order to evaluate additional conditions, I can use the else if statements. In fact, I have two of them here. So if this first evaluation is not true, then we'll continue on and do a second and a third and maybe a fourth and fifth, how many other evaluations you want to do. However, if this is true, then we'll no longer run any of these additional checks. We'll just continue on to line number 33. The same is true here. If this is not true, then we're going to evaluate this next expression. If this is true and we execute the code inside of the code block immediately following it, then we'll just go ahead and skip over this last else if statement and continue on to line number 33. All right. So if we were to run the application, let's go ahead and just quickly run through scenario number 2. Hey, we won a boat. And scenario number 3, which obviously would allow us to win a cat. But then we still haven't accounted for the situation where we type in 4 or anything else like the word or just random letters on the keyboard. nothing really happens in those situations. What we really need is what I would call a catch-all case. And so to do that, we'll just create an else statement at the very end of our if, else, if construct. And so here what we'll do is just set string message equals sorry, we didn't understand. And then console dot write line message. All right. So now we're catching every other case possible, no matter what the user types in. So let's go ahead and run the application. Again, I'll just type in some junk from the keyboard, hit enter, and it says, sorry, we didn't understand, and we continue on. Okay? So that's how an if decision statement works. It also has these optional parts of the else if and the else statements for either additional evaluations or what I call the catch-all, just in case none of the conditions are true. Okay. Now, there's a couple of things about this, and we're going to continue on and talk about one other type of decision operator that we can use, a conditional operator. But before we do that, here's an opportunity to clean up our code. Let's look for areas where we've essentially got the same code repeated over and over and over again. And I can see a couple of instances where this is true. The first would be where we have this console.writeLine message. You see we've repeated that in line 20, 25, 30, and 35. Wouldn't it be great to keep our code a little smaller and only use that once at the very end of our evaluation, like put it right there, outside of the if, else decision statements. All right. So let's go ahead and just remove those from there completely. All right. But when we do that, notice that I'm getting a red squiggly line under the word message. The name message doesn't exist in the current context. All right, so we're going to talk about scope and declaring variables inside of certain scopes in a little bit, but just to kind of lead up to that conversation, essentially when we've defined a variable inside of an inner scope, it's not available outside of that scope. In other words, if we define a variable inside of a code block, inside of the curly braces, it's only available inside of those curly braces, not available outside of those curly braces. So what we'll have to do is define that message variable outside of our if statements so that it's accessible to all of the inner code blocks as well as our console.writeLine message here in line number 35. So it's a very simple fix. We'll just do this string message equals, and then we'll just set it to an empty string to begin with. All right, so now you'll see a different message, a red squiggly line, but we've seen this before. You can't define the same variable twice, even if it's in an inner scope. So what we'll do is just say, instead of defining the variable message there, we'll just set our existing string variable called message to the value like so. Okay, great. So now our application should run. We've eliminated a lot of code, and admittedly I created a straw man here. I wrote more code than I needed to, but I wanted to illustrate this point. So again, if we were to run the application, it works correctly. But there's one other change that we can make. Code blocks inside of, as we're using them inside of if, else if, and else statements, if there's not more than one line of code to execute, then we don't even need to use the curly braces. In other words, since there's just one line of code here underneath my if statement, I can just remove it and make it small like that, real compact. Same is true here, and same is true here. Now, in this case, maybe just to kind of illustrate why you would need the open and closing curly braces, if I were to do this, message equals message plus you lose, like so, and I'll even add a little space here to make it look correct. Let's go ahead and test that else case just real quick. And I'll type anything in there and hit enter. And says, sorry, we didn't understand, you lose. Notice that we were able to concatenate two strings together. I did it on two separate lines, don't really need to. But if I were to attempt to remove the opening and closing curly braces there, we're going to get a very different result when we run our application. So for example, if I hit 3, notice that you won a new cat, you lose. Wait, what? How? Why did that happen? You won a new cat, but you lose. Well, there is no such thing as a free cat, but at any rate, it's because what it's really seeing is this, like that. All right. If we want these two to be evaluated together inside the same code block, we have to include them in the same code block. Otherwise, this being outside of that code block will execute no matter which of these if or else if conditions are true. All right, so let's go ahead and put that back in there just to kind of illustrate that idea. In fact, if we were to do something like this, I can even make this a little bit smaller. Let's comment that out. And I'm going to show you a new operator, which is just this. Okay. So now instead of going message equals message plus you lose, essentially I'm saying give me whatever's in the variable message, concatenate on the word you lose, and then assign that back into the variable message. That's what I did here. I just do it all in one step right there where I say whatever's in the variable message, on the end of that concatenate you lose. So this is the assignment and concatenation operator kind of combined into one. Okay, just a little shortcut there. All right, so now let's do this. Let's talk about another style of decision statements. It's actually an operator called the conditional operator, and this works well if you have an if or else kind of scenario and you don't have multiple items to evaluate like we did here. So I'm going to copy some code from lines 14 and 15. Whoops. Yeah, and line 16 too. Let's just copy all of those and we're going to paste them down below our commented area. All right. And then what I'm going to do is this. This. We'll do this a little bit different this time. Okay, there we go. Now I've written a lot of extra code that I need to. I'm going to show you how to shorten this up in just a moment. All right, so here the key to this is this little evaluation that I'm doing on line number 42. Remember that we're going to evaluate anything in between of the parentheses whenever we see the double equal sign. That means we're doing an evaluation. Is the user value that they typed in and submitted through the previous line of code, line number 40, is it equal to the literal value 1? If that is true, if this equates to true, then what we want to do is everything after the question mark, we're going to take that value and assign it to our new variable called message. All right, so if the user types in 1, we'll find the word boat, the literal string boat, and we'll assign it to the variable message. However, if this equates to false, so they type in something different, then anything after the colon will be taken and assigned to the variable message, and we'll use that below. So let's go ahead and run the application. We'll run it twice. We can choose a door, and if they choose door number 1, they win a boat. However, if we run the application a second time and we choose anything else, then you'll only win a strand of lint. Again, this is only useful in a if-else condition, not when you have multiple conditions to evaluate. All right, now let's address this last little part here, because I can shorten this up considerably. Notice in order to get it all to print out on one line, I only use console.write. And so then I typed out the literal string, and then I have a second line where I'm actually then printing out the actual message from line 42, and then finally to add a period at the end, I'm having to do yet another console.write statement in order to add a period. Okay, I can shorten all that up in one line of code. Watch how I do this. In fact, let's go ahead and I'll comment out these lines individually like so, and then I'm going to use a replacement character inside of the console.write line in order to shorten this up a little bit. So we'll use a write line instead, and we'll put U1A, and then I'm going to use what I call a replacement code. So a replacement code of 0, and then after I give it that literal string, I'm going to use a comma, and then give it the actual message variable that I want. Whatever's inside of this, I want it replaced in here. Okay, so eliminate that the curly braces with the 0 and put the message variable value inside of there. So let's run the application again just to see this working. I'm going to type the number 1 and you get the same result. All right. Now, what if we wanted to expand on this idea here? Let me comment that out. And what if I wanted to replace 2 values inside of that console.write line string? So let's do something like this. You entered, and then we'll go 0. Therefore, you won a. All right. And so in this case, after the comma, I'm going to enter the user value and then the message here. Let's make sure you can see that. All right. Hopefully you can see that all on screen at one time. So I need to do one little thing here is change that to a 1. All right. So this says take the first item. So in software development, typically you don't start with the number 1, you start with the number 0. I don't know. So we're going to see this pop up again and again. So the first item in the list will be at element 0. The second item in the list will always be at element 1, and so on. All right. So the very first item, this will be matched and replaced by the very first item in that comma delimited list of input parameters after the literal string, that little template that we've created for ourselves. Then here we're going to do a second replacement and replace that with whatever's inside of the message variable. So when we run the application and we type in the number 1, said you entered 1, therefore you won a boat. Awesome. All right. Okay, so that's enough for one lesson. Hopefully you've learned a couple of important things in this lesson. First of all, we talked about the if decision statement as well as the else if and the else, and how to do a comparison, an evaluation between 2 values to determine true or false. If we're using an if statement and we're doing that evaluation, then anything, the code that is in the code block below it will get executed if that evaluation is true. If it's not, it'll either drop down to a second and subsequent evaluation or even do a catch-all in the else statement. We talked about using curly braces for a code block versus when you don't need them. We talked about keeping your code nice and tidy and small. We talked about declaring variables inside of scope and inner scope and outer scope as defined by our curly braces for code blocks. We talked about the conditional operators being able to all in one line do a check for true or false, and if it's true, assign one value versus a different value to a new variable. We talked about format codes inside of literal strings for our console.write line and how to replace those replacement codes with variable values that we then also pass in our console.write line statement, like you see here at the very bottom in line number 49. Okay, so again, covered a lot of ground. Hopefully this all makes sense. If not, rewatch the video. Just watch those portions that didn't make sense. Make sure you're typing in the code yourself so that you can come to some of these epiphanies as you're typing. Okay, all right, we'll pick it up in the next lesson. See you there. Thanks.
That's all for this episode. I hope this tutorial was helpful. Is your mind ringing with questions, queries, or doubts? Do you wish to learn more? Then visit our website www.millionlights.org and post your questions on our forum. We will be extremely happy to clear all your doubts. If you have missed anything and want to rewatch it, you can download it from our website or you can watch it online as well. You can also participate in our webinars, discussions with the subject experts, as well as get Microsoft certification on various courses through our website. You can also find us on Facebook by the name Millionlights or on Twitter. For more such interesting tutorials on coding, keep watching Microsoft RF Code brought to you by Millionlights. Thank you.